All right, so what we're talking about today is we are talking about writing equations for lines given different information. And so last lesson when we did this, you were given specifically a point, or actually a y-intercept, and the slope. You had to count the slope. All our lines went through our y-intercept, and today that's not going to be the case. So because we're not having specifically the y-intercept, we're going to need a new formula or a new form, which is called point slope form. Point slope form looks a little hard at the beginning, but after we do some of them, you're going to see that it's pretty easy because it's the same every time. So I got 5 different variables there, but you only plug in 3. The 3 you plug in is you plug in the m, the x1, and the y1. So those are the things that you have to find. And once you find them, you're able to plug them in. Okay? A lot of times they're either going to give you the slope, give you m, or you have to use our slope formula. Or you could possibly have to count rise over run. So you have to be willing to do any of those 3 things to find the slope. The x1 and the y1, you always are going to have to be given a point that the line goes through. And so the number here, the first number is the x1, the second number is the y1. So you're always going to be given a point that the line goes through, and so you have to have that. Now, if you're given 2 points that the line goes through, you pick one. It doesn't matter which one you use, in the end, you're going to get the same answer. All right, let's zoom in on the first type of problem, the most basic, where I give you the slope and the point, and we just have to plug it in. So for the first couple problems, I think it's going to be easier if we write the equation every time. If you get used to this and write it a bunch, then you'll have it memorized. So again, I have to identify my m, which it tells me my m there, so that's nice. And then I have a point. And remember, your first x is always x1, and my first y is y1. So I have 3 different numbers I can plug in, so I can plug them in. I don't know what y is, so I write y, but I do know that y1 is 5. I don't know what x is, but I do know that x1 is -2. And I wrote a negative or a minus because it says minus. So now what I'm going to do is, if you notice 2 negatives here become plus. So I get y minus 5 equals 1/2 times the quantity of x plus 2. Now, whenever we have parentheses, I'd like us to distribute. Some people will leave the equation here and say this is good. I would like us always to get it into y equals mx plus b. So I'm going to distribute this 1/2. I'm left with y minus 5 equals 1/2 x. Now, when you have fractions, don't fret over fractions. They're not that bad. You just look at the top. 1 times 2 and divide by the bottom number, which is 2. So 1 times 2 is 2. Divided by my bottom number, 2, is 1. Now I'm almost done because I have a minus 5 here that I have to get rid of, and then my y is totally by itself. So the way I get rid of a minus 5 is I'm going to add 5. Now where you need to be careful is where you add it to. It can't go under an x, so it goes underneath the 1. And so my answer for this problem is 1/2 x plus 6. So 1/2 x plus 6 is the equation of the line that has the slope of 1/2 and passes through the point -2, 5. All right, so you guys are going to do 2 of these. So start off by copying them down. And then when you think you have it, you can press play. So hopefully you started by writing your equation. The more you write it again, the quicker it is to remember it. So my m is 1/3. My x1 is 6, and my y1 is 5. My x1 is actually -6. So it's y minus 5 equals 1/3 x minus -6. So I get y minus 5 equals, I'm going to kind of do this as one step. A negative minus a negative becomes positive. And so now I'm going to distribute. 1/3 times x is 1/3 x. 1/3 times 6. Well, that's 1 times 6 divided by 3, which is 2. Very good. And now I need to get rid of a minus 5. So I add 5 to both sides. So the equation of the line that has a slope of 1/3 and passes through the point -6, +5, is y equals 1/3 x plus 7. All right, let's look at the second one. So this should be y minus y1 equals m x minus x1. So now this is my x1, this is my y1, so I can plug it in. So y minus 4 equals my m, -1, x minus x1, which is 2. I don't have double negatives, so all I have to do is distribute my -1. So I get y minus 4 is equal to -x plus 2. Distributing a -1 is just like multiplying or changing the signs. And now I need to get rid of -4 by adding 4. And so I get y is equal to -x plus 6. So again, if I pass through the point 2, 4, and I have a slope of -1, this is the equation that makes that line. Okay, so that's the first type of problem. Now the second type of problem, the last actually 4 different types, we'll focus on 2 of them, are pretty much the same thing. They just look different. So these last 4 methods, we're going to do the exact same thing each time, but they're in a different format. So I wanted to show you both of all different formats. So x1, y1, x2, y2. So I need to use this formula. So I know my y1 and my x1, so it'll be y minus my y1, which is 3, and x minus my x1, which is 2. The issue is I don't know my m. So when you don't know your m, you either have to use the slope formula or you have to count rise or run, rise over run. Well, I don't have a graph here, so I'm going to have to use my slope formula. So this is, I don't think I gave you enough space for this. So it'll be 4 minus my y1, which is 3, over x2, 0, minus x1, which is 2. And I'm just using this formula here. We did a bunch of this. You should be pretty good at those by now. 4 minus 3 is 1 over -2. So that means my slope is -1/2. It's not good to keep a negative on the bottom of the fraction. You need to put it to the middle or put it on top. So now I'm going to distribute my negative. So I get y minus 3 equals 1/2 x. -1 times -2 is a +2. Divided by this 2 is a +1. And now I need to add 3 to both sides. So my answer is y equals 1/2 x plus 4. So again, what makes this problem a little harder is that you have that extra step of trying to find the slope. All right, so let's look a couple of these problems. So those are number 3, 2, 1, and 3 and 4. Zoom out so you can see. I'd like you to copy those down and try those problems out. So hopefully you started by saying x1, y1, x2, y2. I'll write my formula again, just so it helps me remember it. So my y I don't know, but I do know my y1 is 2. Equals my slope, which I have to find out, and x minus x1, which is 5. So we're going to have to use our slope formula to find out our slope. And so our y2 is 6 minus y1, which is 2. x2 is 3 minus x1, which is 5. So I get 4 over negative 2. And 4 divided by negative 2 is a negative 2. So my m's negative 2. So now I'm going to distribute this. So I get y minus 2 is equal to negative 2x plus 10, because a negative 2 times a negative 5. And now I just have to add 2 to both sides. And so you get y is equal to negative 2x plus 12. And that's the answer for that problem. So if I ever have those coordinates, this is the only line that will go through both of them. So number 4 was the same process. X1, Y1, X2, Y2. I'm going to write my form again just so I get used to it. Don't know my Y, but I do know my Y1 is negative 2. I don't know my M yet, but I do know my X1 is 3. So again, Y2 minus Y1 over X2 minus X1. That's what my M is. My Y2 is negative 1 minus my Y1, negative 2. And then my X2 is 0 minus my X1 is 3. So now I have 2 negatives here that become a positive. So negative 1 plus 2 is a 1. And 0 minus 3 is negative 3. So that tells me my slope is negative 1/3. Remember that we don't want to put negatives on the bottom. So either put it on the top or in the middle. So I have 2 negatives here. So that's going to become a plus. And I'm going to distribute this here. So negative 1/3 x. Negative 1 times negative 3 is a positive 3. Divided by 3 is a positive 1. And now I'm going to minus 2 on both sides. And I get negative 1/3 x minus 1. So again, what makes this process a little harder is that you have to find the slope formula first. Okay, so now another type of problem is if it's given in function notation. What's nice about this is it's the exact same of what we already learned. So you're not learning a new process. But what you do have to recognize is that this is my x1 and this is my y1. This is my x2 and this is my y2. When I plug in a 2, I get a 3 back. When I plug in a negative 2, I get a 1 back. So when I plug in my formula, my y1 is 3, my x1 is 2. The only thing I have to do is my slope formula again. So y2, which is 1, minus my y1, which is 3, over my x2, which is negative 2, minus my x1, which is 2. So I get negative 2 over negative 4, and negatives become positive, and 2 over 4 reduces to 1/2. So now what I'm going to do is I'm going to distribute, and I get y minus 3 equals 1/2 x. 1 times 2 is 2. Divide by 2 is 1. And since it was a minus and there's only one negative, it's negative 1. And now I have to add 3 to both sides. And so I get 1/2 x plus 2. Now, I don't want to do more examples like that because that's our 4th problem with using the same process, and we'll have to do one more in a minute. I just need you to recognize that when I have a parentheses, that's the x, and whatever it equals, that's the y. All right, let's go to one that's a little easier. And the reason this one's a little easier is that I can see my slope. I can see that I go up 3 and over 1. So I can see that my slope is 3. So I don't have to use my formula, so that's nice. Now, what I do need to do, though, is I need to pick a point. And it doesn't really matter which point you pick. I could pick my point on the left. I can pick my point on the right. They're both going to give you the same answer. Okay? I'm going to pick the point on the left, which is 1, 1, which is x1, y1. And so it'll be y minus 1 equals my m of 3 times x minus x1, which is 1. I can go ahead and distribute my 3. So I get y minus 1 equals 3x minus 3. And now I'm going to add 1 to both sides. And I get y is equal to 3x minus 2. And so the equation of this line is y equals 3x minus 2. And so these are a little nicer because you can count your slope. All right, last example, because we've been exampled out. If I have a table, really, you could pick 2 points or you can find your pattern. Remember, slope is rise over run, which is really what happens to your y's over what happens to your x's. So let's see what happens to our y's. Our y's, that's a +1, a +1, and a +1. So the change for our y's is +1, so that's what's going to happen. And then it's over the change for your x's. This one's a +2, a +2, and a +2. So I just found my slope is 1/2. For the second part, when we need to have a point, it doesn't matter which of those 4 coordinates you choose, they will all work. I think I'm going to choose the easiest one, which is here, because it's positives and zeros, and positives and zeros are easy to work with. So this would be my x1, and this would be my y1. Again, you could choose any of those 4 sets of points, it'll still work. So it'll be y minus my y1, which is 0, equals my m, we just found is 1/2, x minus x1, which is 4. Well, y minus 0 really doesn't do anything. That doesn't matter. So now I just have to distribute. So I get 1/2 x, and 1/2 times 4 is 1 times 4 divided by 2, which is 2. Okay. All right, so these problems have a little bit more of a process. You have to plug in 3 different things. And the hardest thing about this is when you're not given your slope and you have to find your slope. And remember, you can find your slope by counting rise over run or by using your formula y2 minus y1 over x2 minus x1.